All right, so for today, we're going to go over 6.2 first, then 6.3, okay? And that's going to all be on your quiz that's coming up tomorrow. So here's the first question. And all of these are basically just simplify, all of these questions. Okay, so simplify the following. So part A, we'll do 3 radical 3 plus 2 radical 3 minus 6 radical 2. Or square root of 3, square root of 3, square root of 2. I always say radical, but that would be square roots to be exact. Remember, the word radical just means it's like a root in general. Saying square root means it's specifically a square root, specifically a cubed root, right? So if you hear me say radical, I'm just saying in general, there's a root there. So 3 square root of 3 plus 2 square root of 3 minus 6 square root of 2. So you got to just combine these things, right? Remember, you can add things that are like roots, right? Like radicals. So I do have two of them, right? The square root of 3 and the square root of 3. So I can put those together. So 3 square root of 3 plus 2 square root of 3, that's going to give me 5 square root of 3 minus 6 square root of 2. Now, the square root of 3 cannot be simplified anymore, and the square root of 2 cannot be simplified anymore. So since they are not like radicals, then I just leave it like that, okay? I've seen too many of my students doing this. 5 minus 6 is negative 1, and then 3 minus 2 is 1, right? So they're still combining. You cannot put those together anymore. Once they're like that, if the radicals or the square roots don't match up, you can't just combine them anyway, all right? It's like saying 5x minus 6y, you're going to put negative xy. I know people do that in the very beginning when you first start learning, variables and stuff, but they're not like terms. You can't put them together, right? So you would just leave it 5x minus 6y. So same with this, just leave it like this, okay? So usually these problems are not meant to be super difficult, but sometimes based on the numbers they give you, it can take you a little bit longer to simplify. All right, so let me give you one that looks a little different that we are going to have to do some work for. So negative 2 square root of 2 minus 4 square root of 8 plus 6 square root of 8. Now, the first thing I always recommend is that you combine your like radicals first, okay? Try not to break them down first, because if you break them down, then you're going to break down the 8 2 times, right? There's no reason to break down that square root of 8 2 times. Just combine it first. So find anything that they have in common. So negative 2 square root of 2 has nothing in common with anything else yet. Negative 4 square root of 8 plus 6 square root of 8 is a positive 2 square root of 8. Okay? Now at this point you got to ask yourself, okay, these are not like radicals, so can I make them like radicals? So I look at the first one, 2 radical 2, or 2 square root of 2. I can't do anything with the square root of 2, but the 2 square root of 8, I can break down 8 into a 4 times a 2. So let me write that out. Negative 2 square root of 2 plus 2 square root of 4 times 2. By the way, I was asked last time, do I have to show this work for 4 times 2? And no, you don't. Remember I told you guys, I show you the steps because I think people who need it might want to see it. But if you don't need it, then it's fine. Don't write it down. Just go to the next part. Okay? Now, a mistake that I still saw a couple times in the last quiz. When you take out a number from the square root or a cubed root, make sure you apply the rule. So if you're taking out the square root of 4, that's going to be 2, not 4. So you're taking out the 4, but it becomes a 2. Okay, don't take out the actual 4, because then you're going to have 2 times 4 on the outside. You're taking out a 2 from that square root. Okay, so it's negative 2 square root of 2 plus 2 times 2, because that's the square root of 4. And then square root of 2, that's this number right here. Okay, in case you're wondering where all these 2's coming from, there's that. Okay, the 4 became that 2. Okay, so I applied the rule of the square root to it. Like I said, I saw a lot of people taking the 4 out, and instead of that green 2, they were putting a 4 right there. So they were multiplying incorrectly. So all right, let's keep going here. This is a negative 2 square root of 2 plus 4 square root of 2. And since these are like radicals, negative 2 plus 4, that's 2 square root of 2. And there's your answer. Any questions on this one? This one was a little more complicated because we actually had to do something with the radicals, right? We had to break down a number. Whereas the other one, we just had to combine stuff. So those aren't too bad. And you will have stuff that's that easy, like the example 1 where you're just kind of combining a couple things and you're done. But then there will be some where you're going to have to break stuff apart. Maybe numbers bigger than 8, like 24, 32, 16, stuff like that. So just make sure that you guys go through it slowly. You're going to have your calculator, so that should help. but just kind of take your time. All right. I know some people are like, oh, this is easy. I can go through it real fast. Yeah, but then sometimes when we do it really fast, we make mistakes. We don't see it. And then we get things wrong that we shouldn't be. So. All right. Let me try to give you guys something with the cubed root, and then we'll move on to the stuff that you did on Friday. So I'd rather spend a little bit more time on that since maybe you have questions. So this is going to be part C. So again, everything we've done so far has been section 6.2. Okay, the addition and subtraction one. Okay, so here we go. Negative 2 cubed root of 32 plus 6 cubed root of 4 minus 5 cubed root of 2. So these are cubed roots. So again, there's only 5 cubed roots that I asked you to memorize. The cubed root of 1, cubed root of 8, cubed root of 27, the cubed root of 64, and the cubed root of 125. Okay, that's going to be 1, 2, 3, 4, 5 respectively. So those would be really good for you guys to know. Okay, the rest of them, I mean, sure, it's great, but you don't need to know them. You have calculators as usual. So here we go. First thing I'm going to notice is that none of my roots, my radicals, are the same. Okay, so that means I'm going to try to break stuff down immediately. Okay, so I look at the 32 and I can break that one down. Okay, so this is going to be negative 2 cubed root of, and now I have to think, okay, I know I can break 32 down into 16 times 2, and that has a nice square root, 16, but I'm not doing square roots, I'm doing cubed roots. There is no cubed root to 16, but 8 has a cubed root, right? Cube root of 8 is 2, and 8 times 4 is 32. So I can break this down to 8 times 4. That was another little mistake that I noticed some people were doing. When you were breaking this stuff down on your last quiz, even though it's a cubed root, a lot of you guys were still doing square roots. So you'd break things down to like 25 times 2, and then you take out a 25 and you take its square root. But we were doing cubed roots, right? So you were still using the same rules of square roots for everything, right? So pay attention to the index. The index is cubed root, okay? Now the other stuff I'm just going to kind of write out because I can't really break down the number 4 into anything that has a cubed root, with the exception of 1, but we never go to a 1. Same with the 2 here, so I'm just going to kind of leave it like that. Now, what is the cubed root of 8? Say again? A 2, right? Cubed root of 8 is 2, because 2 times 2 times 2, that's 8, right? So here we go. Let's rewrite that here. Negative 2 times 2 cubed root of 4 plus 6 cubed root of 4 minus 5 cubed root of 2. Okay, remember this little 8 here becomes this 2 right there. All right, so if you're wondering where did the 8 go, well, it becomes a 2. We don't take out the actual 8. Like I said, that was kind of a mistake that people were making every once in a while, taking out the actual number inside of the radical. We got to apply the radical to it, right, when you take it out. So, all right, negative 2 times 2, that's negative 4. Cubed root of 4 plus 6 cubed root of 4 minus 5 cubed root of 2. Again, I know I'm taking all my steps, but this is just in case. Now I can combine the first two terms, right? The negative 4 cubed root of 4 plus 6 cubed root of 4. That's going to give me a 2 cubed root of 4 minus 5 cubed root of 2. And like I said before, once we're done simplifying as much as possible, if that's all we got and we can't combine them, then that's fine. Okay? There's a lot of people that start to freak out because they're like, oh man, it's not just one term. That's fine. It doesn't have to just be one term. It can be 2 terms. It can be 3 terms. If they can be put together, don't force it. Okay? Anyway, that's that part C for that. So you guys have any questions on A, B, or C? So I'm just going to kind of go up to A really quick just so you can see it. A was pretty fast. No simplification to really do other than combining 2 terms. B, we had to break down the 8. Okay. So we broke down the 8 and then just combined our like radicals. And then C, what was cubics? So same idea as part B. But it was cubics. Are we good? All right. So example number 2. So this has to do with last Friday's lessons. Okay. So we're going to be simplifying, but multiplication of things. So we'll go with some of the easy stuff first because there will be easy stuff on the quiz. It's not like everything's going to have to be complicated. So here's the first one. Negative 5 square root of 6 times square root of 9. Now, I mean, you can do this one of 2 ways. Okay? You could either straight out just multiply. And what we learned in the lesson was that you can multiply the radicals with each other as long as they're the same type. So square root and square root, you can multiply together. So you can write this as negative 5 square root of 54 if you want. Okay, I'll do it that way right now, but sometimes that's kind of counterproductive. Okay, the easiest thing is to ask yourself, can I simplify those things first if there's anything easy, right? Well, we don't have a square root of 6, but we do have a square root of 9, right? Square root of 9 is 3. So I can actually, and I'm going to do this right here, method 1. So I can rewrite this negative 5 square root of 6 times 3. Because that's what the square root of 9 is. 3 times negative 5, you can multiply that out. That's negative 15 square root of 6. And you're done. Okay, so you'd be done right there. You could do it this way if you want. Sometimes it's very beneficial to do it like that. Let me show you method 2 right now. Other times it's better to break stuff down first. Okay, so let's see what happens with the other method. So method 2. So this one, we broke down the square root of 9 into 3, and then we multiplied and we were done. It seemed pretty quick. Okay. The other method is to multiply your square root. So 6 times 9 is 54. So we get negative 5 square root of 54. Now, if you do that, at this point, you're going to say, okay, I got to break apart 54 into 2 numbers that multiply to 54, and one of them has a square root. Well, surprisingly, it's 6 times 9, the things we just multiplied, right? Or maybe I should say not surprisingly. Right? So the square root of 9, we know is 3. So that's negative 5 times 3. square root of 6, which is negative 15 square root of 6. So notice, same answer. Okay, a couple more steps, but it's okay. You do whatever works for you. Like whatever your mind says, I get that, then do that. Okay, I'm just showing you two different ways. The next problem that I'm going to do, I'm going to show you two different ways as well. Like the same two methods apply to one problem. Just so you can see, it doesn't matter how you do it. You'll get there. Okay, you'll get there. So, let me show you part B. But before I do that, any questions on example A, method 1 or 2? Whichever one you prefer. I mean, it's up to you. I like method 1, but other times I prefer method 2. Like method 1 for this one was the best way to do it. You're going to notice that one I'm going to show you right now, method 2 is the best way to do it. Okay? So how do I know? Just experience. You know, if I do it enough times, I tend to notice certain things. So here we go. Here's part B. Another easy problem, as they say. Okay? And then right now we'll move on to something a little bit more difficult. So here we go. Method 1. Now remember, method 1 was breaking it down immediately. Okay? So, square root of 8, I can break it down into 4 times 2. And then right here I have times radical 2. Okay? And 4 has a square root that becomes 2 square root of 2 times square root of 2. Now my square roots are completely simplified as much as possible. So let me go ahead and multiply them. Square root of 2 times square root of 2, that's square root of 4. And the square root of 4, well, that comes out as a 2. 2 times 2, and 2 times 2 is 4. I mean, this isn't terribly difficult. There's a lot of little steps, but you know, you just you break it down, simplify by taking out the square root of 4, multiply your radicals, and then simplify what you multiply. Okay? That's method 1. This is the same thing I did in the previous example where I broke it down first. Remember, first example, I got the square root of 9 and I said that's a 3. Right? So that's times a 3, not times the square root of 9 anymore. I did the same thing right here. I just broke stuff down first. All right, method 2. What if I don't break it down first and I decide to multiply first? Well, what's the square root of 8 times the square root of 2? It's the square root of what? 16. And what's the square root of 16? It's just 4. Then I'm done. I'm going to zoom out really far back, okay? But I want you guys to notice, sometimes it's beneficial to break it down first. Sometimes it's beneficial to just multiply. Again, how do you know? I just do it in my head real quick. I think 8 times 2, is that good? Oh, that's 16. Yeah, let me multiply first. Right? Whereas in the other one, I said 6 times 9, is that good? 54? I know square root of 9 is 3. Right? So I kind of have to think about it before I just start working. Right? I got to kind of plan, what do I want to do? Do I want to multiply first and then I do it in my head, 6 times 9 is 54? Or do I want to simplify? Well, I don't have a square root of 6, but I do have a square root of 9. Maybe I should break it down first. Okay? Same thing I did with part B. Right? In part B, I said, well, square root of 2, I don't know. Square root of 8, I don't know. I mean, I know I got to break it down. But I know 8 times 2 is 16, and I know the square root is 16. Right? So again, I'm just kind of breaking it apart in my head. I'm thinking, what's better, multiply or simplify? What should I do first? Right? I mean, there's a big difference in the number of steps, kind of, right? So whichever method you want to use is fine. They work, okay? Just take your time doing it. Don't mess yourself up. All right. So I want to do one more of these things, and then we're going to go to one of these variable ones as well. Okay? But this is part C. Because I think, if I remember correctly, you guys had problems like this. Am I right? Did you have some of these foiling problems? I know they look kind of weird, but they're not supposed to be like crazy difficult. Just take your time with them. Do your foiling right first time, your first outer inner last. All right, so let's start. When you're doing this here, square root of 5 times the square root of 5, so that's square root of 25. Square root of 5 times the square root of 4. This is 4. Just sorry about that. So square root of 5 times the square root of 4. That's the square root of 20. Now, I was asked one time, couldn't I have just made that square root of 4 into a 2 earlier? Yeah, you could have. Okay, I'm just going to leave it alone. But you could. All right, next part. Square root of 3 times the square root of 5. That's a square root of 15. And then, thank you. Square root of 3 times the square root of 4. That's going to be the square root of 12. So the thing about these problems, they become a bunch of little problems, right? So square root of 25, we should know that, 5, right? 20 becomes 4 times 5, because I can take a square root of 4. Is there anything I can do with the square root of 15 when I break it down? Is there any good number I can use that has a square root? No, right? 3 and 5 is the best I can do, and none of those have square roots, so I'm just going to leave it alone. Plus square root of 12, well, I do have 4 times 3. Okay? All right, all the square root of 4s can come out and become 2s, so both of these are going to have 2s. So 5 plus 2 square root of 5 plus square root of 15 plus 2 square root of 3. Can I combine anything? Remember, this is addition and subtraction. Is there anything I can do at this point? No, I'm done. Okay? There's nothing wrong with having 4 terms. Like I told you before, you can have 2 terms or more, doesn't matter. As long as there's not any like radicals that you're forgetting. But I simplified it as much as I could, and this is what I got. Okay? There's only one more type of a problem that I want to do with you guys. It's the ones with the letters. Okay? Because you guys had to do that as well. You had a lot of different types of problems in section 6.3. They were all multiplication, but some had like variables, some didn't, some had foiling or distribution, right? There were a lot of different types. So I'm just trying to hit a little bit of each one of those in case you need a little bit more help with that. Are we okay with this one? Again, distribution, that's all you're doing. You're foiling. Okay? So here's the last example. Or maybe last 2, depending on what we see. But this is going to be simplify again, okay? So we are simplifying. See if I can give you at least 2 of them. A cubed root and something that's not a cubed root. All right, so we'll go with this. 5 square root of 15v squared times square root of 6v cubed. Now, when it comes to these types of problems, I usually don't try to simplify early. I just multiply, and then I'll fix it. Because I could always simplify early. I know I can take the v squared out, and it just becomes a v. And I can make that v cubed into a v times v, one on the outside. You know, there's a lot of stuff I can do. But to not confuse myself, let me just leave it. Okay? And I'll fix it. Let's go ahead and multiply straight out. Okay, I'm not doing any methods. Well, I guess I am doing the method. Method 2, just multiplying it out. Okay, so here we go. 5 times, remember, there's a 1 here, okay? There's a 1 right there in the very front. So 5 times 1 is 5. Square root of 15 times 6. That's 80. Yeah, 80. And then v to the 5th. All right. Now I got to think of numbers that multiply to 80. One of them has to have a nice square root. What do you guys think? Anybody? Did I mess up on it? Hold on, let me double check. That's 30, right? Yeah. Oh yeah, you're right, 90. Whoops. Thank you. I was just checking. No, I'm wrong. Hold on, give me a second. I'm gonna write this. Where's my thing? I don't know if you knew, but correct me. You get extra credit, so that's good. You came in after, so yeah, square root of 90. Okay, so now let's think of numbers that go to 90. What numbers go to 90? One of them has a nice square root. One's a 1-digit number, one's a 2-digit number. 9 and 10, right? 9 times 10. Now, what's my index on this square root? Remember the little number in the front? A 2. That means my powers have to be 2's, right? So v to the 5th is v squared, v. So notice those match, right? The powers of 2 right there, they match with my index. That means those are going to come out. So what gets to come out here? The 9 is going to come out. This v is going to come out. So is this v, that one's going to come out as well. So let's go ahead and write that. So 5 times, the square root of 9 is 3 times v, square root of, all I have left is a 10 and a v. Thank you. A 10 and a v. So just multiply it out, 15v squared on the outside. Square root of 10v. And that's going to be your answer. But thank you for the correction, because that would not have been good. So this one I just multiplied through. Now why did I multiply through? Well, because in the original problem, if I look up at it, I don't have a square root of 15. I don't have a square root of 6. So there's nothing I can do to make it easier. Okay? So I just figured, let's just multiply. And 15 times 6, that's not a terrible number, right? It's not like I'm at 1,000 something. So I decided I'm just going to multiply through. Now, this one, I'm going to change my mind. Okay, so go ahead and write that one down. All right, so a cube root of 125 times a cube root of 15, I don't want to do that. That's a big number, right? So I'm going to take the cube root of 125. I know that, okay? Cube root of 125 is 5. Okay, this is coming out. This is a 5 cubed root of n. Notice I did leave the n in there. I didn't mess with it. Times 3. I don't know the cubed root of 15. Okay? Do I know the cubed root of n cubed? Notice index matches power. What's the cubed root of n cubed? If the index matches the power, what do I do with it? I just take it out, right? Just got to take it out. So this is going to become n cubed root of 15. Oops, I forgot to put cubed root. So this one I did simplify first. And the reason was because I noticed 125, that's an easy cube root for me to take, right? I should know those first 5, right? That one I can do. So if I'm going to start simplifying, let me go ahead and do it. Now let's just multiply out these two things. So 5 times 3, okay, these two right here. 5 times 3, that's 15. N cubed root of, now let's multiply the cubed roots. N times 15, that's 15n. There is nothing that I can multiply into 15 that has a cubed root, because 15 is just 3 times 5. None of those have cubed roots. So I'm done right here. Okay, this problem is finished. So this is what's on your quiz tomorrow.